everyone, in this video we will quickly see some bilayer liftoff stack design configuration. So what should we keep in mind when we design our bilayer liftoff stack? Here I am in the recipe book and we can see some details. Again, as mentioned also in other videos, I really recommend you to read this document because it contains pretty much everything you need to know in order to be successful with your processes. In this case, for the bilayer liftoff process, what should we consider? Well, we're dealing with a wet development process. As you can see here, we have typical undercut formation after the development. So because of this isotropic etching process, we have a limited feature density. So if the features are too close to one another, and this will cause the collapse of the structures, so emerging of the features. So what we usually say is that the feature density is nearly twice the thickness of the bottom resist layers, because if we assume an isotropic etching in this direction, then let's say we have 100 nanometers of PMMAMA, and we etch 100 nanometers in this direction and 100 nanometers in this direction, even without considering overdevelopment, then basically we have emerging of this feature if they're around twice as the thickness of this layer. So this is one main thing that we should consider. In these videos, we will fabricate samples and pattern on bilayer liftoff sample with 100 nanometers of PMMAMA. This means that the minimum feature density that realistically we can achieve is around 200 nanometers. Another important thing to keep in mind, we will do an evaporation after the development. What is the thickness of the metal that we can deposit for a successful liftoff? Of course, we cannot deposit, let's say, as much as the underlayer, because otherwise the metal will completely fill the hole that we are creating with the wet development. Also in the recipe book, we have suggestions regarding this specific point. So we recommend a metal thickness up to 40% of the either PMGI or the PMMAMA underlayer. So this is one thing to keep in mind. So if we consider our sample that we will deal with in the next videos, 100 nanometers of PMMAMA means that we can deposit up to 40 nanometers of PPA, of metal during evaporation, my bad, and the minimum feature density is around 200 nanometers. So it will be hard to see features that are spaced 50 or 100 nanometers from one another. So these are the main things that we should consider when designing the bilayer liftoff stack. One last thing that I will say is a kind of a bonus consideration is the design for the laser. Because if we are also using the DLS module, as you may also have seen in a previous video, in the optional tool of the laser configuration, we have the writing efficiency. So depending on the type of stack that we have, so now let's assume that we have our stack with 100 nanometers of PMMAMA, and on top we have 30 nanometers of PPA. Then we have a different writing efficiency with the laser. So another thing that we can consider while designing the stack is this a good or bad stack for writing with the laser? In this case, we can see that it's not so good for both PMMAMA and PPA. So we may have to use a higher power with the laser. So another thing to keep in mind when designing the stack. And yes, I hope this information are going to be helpful for you to understand well how to properly design a high resolution, a bilayer liftoff stack. And again, the most important things to consider are feature density and layer of the evaporated metal that cannot be up to more than 40% of the total thickness. Thanks for watching and see you in the next videos of this series.